Good day, everyone. Welcome to our new day of listening and learning Science 8. Today's video, we are going to learn about the Newton's law of motion. This is Module 2 of Quarter 1, Science 8 subject. Good day, everyone. Welcome to the new day of learning science. This is MELC 1 of Grade 8 Science, Quarter 1. Before we'll start our discussion, let's identify first who were the scientists who studied about or contributed to the Newton's law of motion. So there are two scientists who studied about the laws of motion or motion. One was Galileo Galilei. He was successful in providing the theoretical background on how to describe motion. Another scientist who studied about motion was Isaac Newton. However, it was Isaac Newton who answered why objects move and why accelerate. Newton was able to formulate the answer to these questions into three simple statements. Now we call this one as Newton's law of motion. The first law of motion is also called as the law of inertia. This states that an object at rest will remain at rest, and an object in motion continues in motion with the same speed in a straight direction unless acted upon by an external unbalanced force. This law is often called as the law of inertia. The first law of motion means that all objects have a natural tendency to resist its change in motion. This natural tendency of an object to resist its change in motion is what we call as inertia. This means that all objects have inertia. All objects resist its changes in their state of motion. So let us study the application of this to really understand the first law of motion. Let us examine the animation in the picture. First question, what is the original state of motion? The original state of motion of the skater is in motion. It is moving. So what is the unbalanced force in the picture? The unbalanced force in the picture is the presence of the stone. So what happened to the skater in this picture? The skater changed its motion and changed its direction. So the unbalanced force there is the presence of the stone. This law is the same reason why we should always wear seatbelt. Let us also observe this example. Remember that if the object is acted upon by balanced forces, its motion or velocity will not change. It will only change if the forces acting on it is unbalanced. Another example is the motor rider. What happened to the motor rider is it will change its state of motion because of the barrier. Okay, remember that the greater the mass, the greater its inertia. So the inertia and mass are directly proportional to its other. So an object with a greater mass means have a greater resistance to change its motion because they have greater inertia. So these are the examples of the Newton's first law of motion. First, when riding a car, our bodies move forward when it stops because of inertia. Second, a runner does not stop right away when reaches the finishing line. This is because of inertia. Another one is a motor driver moves forward when it hits a barrier. Another example, a skater stops by stone. This is also the importance of the use of seatbelt because of the first law of motion. These are the key concepts we're going to remember for the first law of motion. First, we have to remember that all objects have inertia. Inertia is a natural tendency of an object to resist its change in motion. Inertia is directly proportional to mass. This means that the greater the mass, the greater its inertia. The lesser the mass, the lesser its inertia. All objects at rest stay at rest, and all objects in motion stay in motion unless acted upon by unbalanced external force. There is also another concept that we have to remember for the first law of motion. So remember that when we are riding in a train or in a car that is at rest, our body will move backward if it suddenly starts. This is the reaction, this is the normal reaction of our body. And our body that is in motion will move forward if it suddenly stops. Okay, let's proceed to the second law of motion. The second law of motion is also called as the law of acceleration. According to Newton's second law of motion, the acceleration of an object is directly proportional to the magnitude of the net force acting on it and is inversely proportional to its mass. This law is often called as the law of acceleration. So what does it mean? This means that everyone knows that heavier objects require more force to move, while lighter objects require less force. However, the second law gives us an exact relationship between force, mass, and acceleration. The second law of motion can be expressed as a mathematical equation in F, or force, is equal to ma. M stands for mass, A stands for acceleration. This means that force is equal to the product of mass and acceleration, or force is equal to mass times acceleration. So based on the second law of motion, we can derive some equations. One of these is, if force is missing, you can use the formula of mass times acceleration. So what is the unit of force? The unit of force is in Newton, or kilogram meter per second squared. Why? This is derived from the unit of mass and acceleration. The unit of mass is in kilogram, acceleration is meter per second. So therefore, the unit of force is kilogram meter per second squared, or you can write it in Newton, or N. For acceleration, we can solve for acceleration using the equation of force divided by mass. The unit of acceleration is in meter per second squared. It is derived from the unit of force, which is kilogram meter per second squared, divided by the unit of mass, that is in kilogram, cancel kilogram, and then kilogram, what is left now is meter per second squared. That is why the unit of acceleration is meter per second squared. Another equation that can be derived from the second law of motion is the equation of mass. How to get mass? To get mass, we're going to divide force by acceleration. So the unit of mass is in kilogram. Why? This is derived from the unit of force, that is kilogram meter per second squared, or Newton, divided by the unit of acceleration, that is meter per second squared. So we have to cancel meter per second squared and meter per second squared. What is left now is kilogram. Therefore, the unit of mass is in kilogram. We can also summarize the equation into this triangle. So if the force is unknown, we can multiply mass and acceleration. Acceleration times mass. If acceleration is unknown or missing, we can use the formula of force divided by mass. If mass is missing or unknown, we can use the formula of force divided by acceleration. Okay, let's have a sample problem. Sample problem number 1. A 1,000 kilogram truck is traveling at an acceleration of 4,500 meter per second squared, 4.5 meter per second squared east. Find the net force needed to accelerate the truck. Okay, so first we have to find the given. One of the given is 1,000 kilogram, that is M or mass. And another given is 4,500 or 4.5 meter per second squared east. This is the acceleration. So what is missing is you're asked to find the amount of force. So the solution is the amount of force, or summation of force, is equal to mass times acceleration. This is written as summation because there are some of the problem that contains more than one force. So we have to sum it, the force, to get the net force. So the summation of force is equal to, substitute now, the value of mass is 1,000 kilogram times the acceleration 4.5 or 4,500 meter per second squared. So 1,000 times 4.5, that is equivalent to 4,500 kilogram meter per second squared. Or you can write that as 4,500 N east. So this is now the answer for force, 4,500 newtons east. Okay, let's proceed to the sample problem number 2. A boy rolls 200 grams baseball horizontally on the floor with a net force of 2 newtons to the right. What is the acceleration of the baseball? Okay, so let's identify the given. First given is 200 grams. This is the mass. Second given is 2 newtons. This is the force. But before we can proceed to the next solution is we're going to have a conversion of 200 grams into kilogram. Why we need to convert this? This is because Newton is in kilogram, not in grams. So what is now the exact conversion of kilogram in grams? The conversion is, in every 1 kilogram, there should be 1,000 grams. So all you have to do is you multiply 200 times 1, divided by 1,000, the answer is 0.2. Then cancel this kilogram, cancel this gram and gram. So what is left now is in kilogram. So the conversion of 200 grams is equal to 0.2 kilogram. And after that, you can proceed to the solution. Okay, so what is asked in the problem is acceleration. If you could remember, the equation for acceleration is force divided by mass. So the force is 2 newtons or kilogram meter per second squared divided by the amount of mass. The mass is 0.2 kilograms. So 2 divided by 0.2, the answer is 10. Cancel kilogram and kilogram. What is left now is meter per second squared. So the answer for acceleration is meter per second squared. 10 meters per second squared. Okay, problem number 3. A box is pushed with an applied force of 20 newtons parallel to the floor. It accelerated at 1.50 or 1.5 meter per second squared to the right. A parallel applied force of 10 newton on the opposite side slowed down the motion of the box. Neglecting friction, what is the mass of the box? So first, identify the given. So first given is 20 newton. That will be the force A, because there are two force A. There are two forces. We have force A and force B. The second force that we have to remember is the 10 newtons. That will be identified as force B. That is opposite to the 20 newtons. So when we say opposite, this is negative 10. So FA is positive 20. FB, force B, is negative 10 because that is opposite to the applied force. Okay, another given is acceleration, that is 1.50 meter per second squared. So A is equal to 1.50 meter per second squared to the right. So let's proceed. So this is the illustration for problem number 3. So as you can see, force A is 20 newton. The opposite of that, the other force is the opposite of 20 newton, that is 10 newton. So this becomes negative, and the acceleration is 1.50 meter per second squared. The solution is summation of F or F net is equal to positive 20 newtons plus negative 10 newtons. So subtract, get the sum of this, 20 plus negative 10, the answer is positive 10 newtons. So this will be the net force. Okay, summation of force is equal to mass times acceleration. So what is asked now is find the mass. So the equation for mass is force divided by acceleration. The force now is 10 newton. The net force is 10 newton divided by the acceleration. The acceleration is 1.50 meter per second squared. So 10 divided by 1.50, the answer is 6.67. How come this becomes kilogram? Because it's in mass. So 6.67 kilogram. That is the answer for problem solving number 3. So to really understand the second law of motion, we have to identify the relationship between the following. So first, between force and mass. What is the relationship between force and mass? The relationship is force is directly proportional to the mass. This is because the greater the mass of the object, the greater the force needed to move the object. Second relationship that we have to remember is the relationship between force and acceleration. So the relationship between force and acceleration is acceleration is directly proportional to the force. This means that the greater the force, the greater the acceleration. The lesser the force, the lesser the acceleration. Another relationship is the relationship between acceleration and mass. So the relationship between acceleration and mass is acceleration is inversely proportional to the mass. This means that the greater the mass of the object, the lesser its acceleration. The lesser the mass of the object, the greater its acceleration. So it's inversely proportional. So to clearly explain the relationship, let's have an example of this. Okay, Mike's car weighs 1,000 kilograms and it is out of gas. So Mike is trying to push the car to the gasoline station and he makes the car move or go in 0.05 meter per second squared. Okay, using the Newton's second law of motion, you can now compute how force of Mike is applied to the car. Okay, so this is the solution. So force is equal to mass times acceleration. The mass is 1,000 kilogram times the acceleration of 0.05 meter per second squared. So multiply 1,000 times 0.05. The answer is 50 newtons. So the answer for force is 50 newton. But my question is, what happens if we're going to increase the mass of the car into 2,000 kilogram? What will be its force? Okay, so we all know that the force is 50 newton if the mass of a car is 1,000 kilogram. So let's make this into 2,000 kilogram. So force is equal to 2,000 kilograms times the acceleration is 0.05. The answer for force is 100 newtons. So what do you observe with the amount of force? We can say that every time we double the mass, what happened to the amount of force applied is also doubled. So we can say that if the mass is doubled, the force is also doubled. So mass and force are directly proportional to each other. Okay, let's see the relationship between the mass and acceleration. Let us say we're going to use 50 newtons constant. So using 50 newton, if the mass of a car is increased to 2,000 kilogram, what will happen to its acceleration? So this is the solution. So we all know that acceleration is equal to force divided by mass. So let us say the force is 50 newton and the mass is 1,000 kilogram. You will have an acceleration of 50 divided by 1,000. The answer is 0.050 meter per second squared. So meaning the acceleration of a car is 0.050 meter per second squared if the mass of a car is 1,000. What if we're going to make that into 2,000 as the mass of a car? So let us say the force is 50 newton divided by 2,000. That's the mass of the car. So what is now the acceleration if we're going to increase the mass of a car into 2,000? The answer is 0.025 meter per second squared. So what do you observe with the amount of acceleration? As the amount of mass is increased, we can say that if we increase the amount of mass, what happened to the acceleration is it will decrease. Okay? Thus, if the mass is doubled, the acceleration is decreased. So the relationship now between mass and acceleration is mass and acceleration are inversely proportional to each other. Okay, if the force is doubled, the acceleration also is doubled. So acceleration and force are directly proportional to each other. So these are the examples of Newton's second law of motion. First, throwing a paper and stone at the same time, at the same height, will have. Second is, easier to push a lighter object than a heavier object. Then second, another one is a ball thrown in a ring after applying a greater force. And any situation that shows acceleration is an example of the second law of motion. The third law of motion is also called as the law of action-reaction. The third law of motion states that in every action, there is an equal and opposite reaction. This law is often called as the law of interaction. So these are the examples of the third law of motion. So let us see, releasing the air in the balloon. So the action there is an air moves, and then the reaction is balloons move backward. Another one, when we're going to use the skateboard, so the action there is if your foot pushes the skateboard on the ground, that will be the action. The reaction is your body will move forward. This is another example of a third law of motion, the cannonball. So the ball force, this is the force of the ball, and then that's the action. The reaction will be the force on the cannon. Another one is the action is air pushes down, and then the reaction will be the balloon goes up. So there are some examples of the third law of motion. These are the examples of the Newton's third law of motion. One is hitting a baseball by a bat. When swimming, our arm pushes backward and water pushes you forward. Another one is when walking, your foot pushes the ground backward, and then the ground pushes your foot forward. So this ends my discussion for today. Thank you for listening. Have a nice day, everyone.